A bridge must be built with the proper materials in the correct arrangement in order to remain stable. Similarly, chemical bonds form when stability is achieved by a particular combination and arrangement of atoms. Hi, and welcome back. In today's science episode, I will talk about stability in bonding.
Science segment: Stability in bonding. The matter around you includes pure elements such as copper, sulfur, and oxygen. But like many other elements, these elements combine chemically to form compounds when the conditions are right. For example, the copper in the Statue of Liberty combines with oxygen and sulfur in the air to form a number of different compounds, including copper sulfate. Copper sulfate is one of the compounds responsible for the blue and green color on the Statue of Liberty. New properties. A compound formed when elements combine often has properties that aren't anything like those of the individual elements. For example, potassium iodide, like is shown in the picture, is a compound made from the elements potassium and iodine. Potassium is a shiny, soft, silvery metal that reacts violently with water. Iodine is a blue-black solid that turns to a purple gas at room temperature. Would you have guessed that these elements combine to make a white crystalline salt? Formulas. Every element has a chemical symbol. For example, the chemical symbol Na represents the element sodium, and the symbol Cl represents the element chlorine. When written as NaCl, these symbols make up the formula for the compound sodium chloride, and that is actually how we read this, sodium chloride. A chemical formula shows what elements a compound contains and the exact number of the atoms of each element in a unit of that compound. Another compound with which you are familiar is H2O, which is more commonly known as water. This formula contains the symbols H for the element hydrogen and O for the element oxygen. Notice the subscript number 2 written after the H for hydrogen. Subscript means written below. A subscript written after a symbol tells how many atoms of that element are in a single unit of the compound. If a symbol has no subscript, the unit contains only one atom of that element. A unit of H2O contains 2 hydrogen atoms and 1 oxygen atom, as this photograph shows. An atom is chemically stable when its outer energy level is complete. The outer energy levels of helium and hydrogen are stable with 2 electrons. But these are the exceptions. Hydrogen and helium, they just need 2 electrons to be balanced or stable. The outer energy levels of all other elements are stable with 8. The noble gases are stable because they each have a full outer energy level. Notice that they have 8 dots around Kr, which represents krypton, Ne that represents neon, Xe that represents xenon, Rn that represents radon, and 2 dots around He, which represent helium. Hydrogen and helium, the elements in period 1 of the periodic table, can hold a maximum of 2 electrons in their outer energy levels. Hydrogen contains 1 electron and its lone energy level. The dot diagram for hydrogen has a single dot next to its symbol. This means that hydrogen's outer energy level is not full. It is more stable when it's part of a compound. In contrast, helium's outer energy level contains 2 electrons, as represented by its electron dot diagram, with 2 dots, a pair of electrons, next to its symbol. Helium already has a full outer energy level by itself and is chemically stable. As a result, helium rarely forms compounds. Compare the electron dot diagrams of helium and hydrogen below. How does hydrogen or any other element change the number of outer electrons to become stable? Atoms with unstable outer energy levels can lose, share electrons, gain electrons in order to have a stable outer energy level. They do this by combining with other atoms that also have partially complete outer energy levels. As a result, each achieves stability. Gaining and losing electrons. This picture shows an electron dot diagram for sodium, Na, and chlorine, Cl. When they combine, sodium loses 1 electron and chlorine gains 1 electron. You can see from the electron dot diagram that chlorine now has a stable outer energy level similar to a noble gas. Sharing electrons. A hydrogen atom has 1 electron in its outer energy level, so it needs 1 electron to fill its outer energy level. An oxygen atom has 6 electrons in its outer energy level. It needs 2 electrons for its outer level to be stable with 8 electrons. Hydrogen and oxygen become stable and form bonds in a different way than sodium and chlorine. Instead of gaining or losing electrons, they share them, as it's shown in the pictures. Hydrogen and oxygen share electrons to achieve a more stable arrangement of electrons to form water. Chemical bond formation. When atoms gain, lose, or share electrons, an attraction forms between the atoms, pulling them together to form a compound. This attraction is called a chemical bond. A chemical bond is the force that holds atoms together in a compound.
I hope you found this video useful. Thanks for watching and until the next one. Bye!